Hey everyone, welcome to the Congruence video. For our this unit, our essential question is, how can you determine congruence and similarity? Our goal today is to prove that figures are congruent using transformations and corresponding parts. So some of our vocab for today is congruent, and that means they're having the same measure sides, same measure angles, and that is staying consistent. In the case of shapes, if one image can be obtained by matching up the first image by a series of rotations, reflections, or translations, that means that the two shapes are congruent. So for instance, what we're looking at down here, these two triangles that are being translated, this triangle ABC is congruent to the image ABC because all I did was take this shape and shift it over. I could take this original shape and shift it over and it would match exactly on this one. Same thing here with the reflection. I can take this shape ABC, the pre-image, and if I flip it over the line onto this shape, all the lines and angles are going to match up perfectly. Again, same thing with our rotations. So we can use our transformations from last unit to help us determine congruence. Another vocabulary word that we're going to be talking about is corresponding parts, or parts of the congruent figures that match. So in this example right here, you can see that triangle ABC is congruent to DEF. If I flipped this one over onto this triangle, they would match up perfectly. Their angles are all the same and their sides are all the same. They are congruent figures. So corresponding parts, when we're talking about corresponding parts, we're talking about the sides that match up. So in this case, side AB matches up directly with side DE. So that's indicated by this marking a line right here, one line. That means that AB is the same length and it corresponds, or it's the same part of the triangle on DE. Same thing that you can see here with this line, CA. Okay, you'll notice that there are three marks here, and you'll notice three marks on that exact same side of the triangle, the corresponding triangle over here. So this indicates that DF is the exact same side as CA or AC. So when we're looking to determine if a figure is congruent and we're using transformation to prove that, this is how we're going to do it. You can look at these two triangles that I drew. Now they're not perfect because I am not an artiste. However, if you look at them, they basically look like the exact same triangle. You could argue that they are the same triangle. They are congruent right off the bat. But in math, we need to make sure that we have proof. So we're going to prove that triangle ABC is congruent to triangle XYZ by using some transformation. So if I'm looking at these two triangles, it looks like I could flip this triangle over and shift it down and it would fit right on top of triangle XYZ. So that's exactly what I'm going to do. I'm going to start by first taking my triangle A, B, C, and to flip, when we're talking transformation, means reflection. So I am going to reflect triangle ABC over this line to create a new triangle here's my new triangle image after it's been reflected over my line. So now it looks like it pretty much will match up with XYZ. So after my first reflection, now all I need to do is slide my triangle to my other figure and see if it matches up. So if I took these points and I would slide it up or translate it, you can see it will pretty much match up, especially if I was a much better artist. Okay, so in order to describe this, to say yes, these two triangles are congruent, and using transformation in my explanation, I would say yes, they're congruent because if I first reflect triangle ABC, then translate or slide the triangle up, they match. So the sides and angles match up after these two transformations. That's how I would explain my reasoning. So let's try one more. Determine if these two figures are congruent by using transformations and explain your reasoning. Well, these look kind of similar to what I just did. I could start by looking at my figure, and it looks like I'm going to need to reflect this figure and flip it over. So I'm going to do that first. So my first way, I'm going to flip this figure Alright, so my first move was that I flipped it, or I used my reflection. Now I'm looking to see, okay, can I just translate it? Can I move it up, this figure now, up onto my second image, and will it match up perfectly? If you can see, it actually will not match up perfectly because this piece of our original second figure is on the third box up from the bottom of the figure. And in this figure, this shape, it's only 2 up. So even if I could shift this up right now, it's not going to match perfectly. So how do I explain that? Well, no, these aren't congruent because after a one reflection, and translation, that's my second move, these shapes do not match up. So that's how we explain congruence with transformation. The other way that we can talk about congruence is we're talking about congruent statements between those corresponding parts that we talked earlier. So, for instance, in these two triangles, if I is congruent to J, I'm going to indicate that again by making a swoosh, a swoop by that angle, just one. Now I know that I is corresponding with J, and they're congruent. Again, I would do the same thing for all my angles. So H is my second angle. that angle is congruent to K. I'm using two swoops to make sure that whoever's looking at this problem knows that H is congruent to K. It's a different marking. Same thing here for G. G is going to have 3, the same as L, because G matches up with L if I would translate my red triangle over onto my blue triangle. G and L match up perfectly. They are corresponding angles. I can do the same thing with my sides. This side matches this side matches this side, and this side matches this side. So what we're asking when we're talking about using corresponding parts and writing congruent statements is this. I want to know angle I, that's how I write it, angle I is congruent. The sign for congruence is this, an equal sign with a swoop on the top. Angle I is congruent to angle J. That is a congruent statement. So I'm going to write that for all of my angles. Angle H is congruent with angle K. Angle G is congruent with angle L. I would do that for all of my angles, and then I also need to do it for all of my sides. So when we're writing sides, when we're writing down congruent statements for sides, we label the side with both letters on the vertices of that side. So for instance, the first side that I'm going to talk about right here on this figure is IH. So I'm going to write that over here. IH, and I put a line over the top indicating that it's a side, is congruent to the side over here, which is JK. Now notice I'm starting with the same letter on the side. So if you're going to start with the lowest letter on this side, you need to do the same here. Okay? So then again, I can write the side IG is congruent with JL, and HG is congruent with KL. These statements that I just wrote are congruence statements. I'm indicating which angles and parts correspond to prove that these two triangles are congruent. All right, so let's put our two skills together. Are using our congruent statements and those corresponding parts, as well as using our transformations. So triangle RST right here is congruent to the triangle UVW. Write a congruence statement comparing the corresponding parts, then determine which transformations map RST onto UVW. So I'm going to start with the transformations because sometimes it might not be as easy to visualize it if the shapes are not going the same way, which angles correspond. And maybe you don't need to do this, but this is just how I would start. So I am going to reflect my triangle UVW so that it's flipped and it will look just like my triangle RST. So again, if I am reflecting over this line, I am going to 1, 2, 3, 4, draw my reflected shape. And I know I'm off my graph a little bit. So this is my new point W, and this is my new point B. Now this helps me visualize that this triangle corresponds directly here. I could slide it right down onto this triangle RST, and it would match up perfectly. So when I'm writing my statements, again, I'm going to do angles, and I'm going to do lines. So I'm going to start with my angles of my triangle R, S, T, and those are congruent to angle R is congruent to angle U. Angle S is congruent to angle V. And angle T is congruent to angle W. Again, I'm going to do the same thing with my sides. So if I start here with RT is congruent to angle UW. RS is congruent to UV, and TS is congruent to WV. Those are my congruence statements for this example. Now I'm going to talk about what I did or what I would do to make sure that, or to prove that these two are congruent. So again, using my transformations. So I reflected my shape first, and now I would need to translate it. You might be asked at some point to say how far you translated the object. So again, we know how to do this. We did this last unit. So if I start here at U and I need to get down to R, I'm going to go 1, 2, 3, 4, 5, 6 units left. So I'm going to translate 6 left, and then I need to go 1, 2, 3, 4 down. This is going to show how I can map or take my triangle UVW and put it right on top of my triangle RST. If you have questions on this, you can ask in class. I'll be always available to help. Last but not least, we always finish a video with a joke. So, what do you call birds that stick together? If you think you know, share it with us in class.